Hello, this is section 7.1, Rational Expressions and Operations. Part 1, Rational Expressions. Definition 1. A rational expression is an expression of the form p over q, where p and q are polynomials and q is not equal to 0. For example, 2x squared plus 3x minus 7 over 4x minus 5, 2x plus 1 over 3x, 5x minus 7 over x squared plus x plus 1. These are all examples of what rational expressions are. Recall, the domain of an algebraic expression is the set of all inputs, normally x values, but not necessarily, for which the expression is defined as a real number when evaluated. The domain of a rational expression is the set of all real numbers except the values that make the denominator q equal to 0. Example 2. Determine the domain of each expression. You should be able to express your answer in words, interval notation, and inequality notation. So again, we just want to find the domain, and it's when the denominator is not equal to 0. So for part A, we have 4 over x minus 2. The denominator is x minus 2. We do not want that to equal 0. Add 2 to both sides, and we get x cannot equal 2. So there's inequality notation, and then interval notation would be negative infinity to 2, union 2 to infinity. Part B, 2x plus 5 over 8. So again, it's undefined when its denominator equals 0. But 8 never equals 0, so here the domain will be all real numbers. Or negative infinity to infinity. Part C, x over x squared minus 1. Well, that means x squared minus 1 cannot equal 0, because that's in the denominator. Now, we solve this like we did in chapter 6. So I'm going to factor x squared minus 1 using difference of squares. So then we get x minus 1 cannot equal 0, and we get x plus 1 cannot equal 0. So we get x can equal 1, and x cannot equal negative 1. So there is inequality notation. Interval notation would be negative infinity, negative 1, union negative 1 to 1, union 1 to infinity. A lot of students forget this middle interval, but we're just saying x can't be 1 or negative 1. It can equal the numbers between those two numbers. That's why we need that middle interval. Part D, 4p over 5q. Well, that means 5q cannot equal 0. Divide by 5, divide by 5. Q cannot equal 0. So that means in interval notation, you get negative infinity to 0, union 0 to infinity. Part E, a plus 10 over a squared plus 4a plus 3. So we get a squared plus 4a plus 3 cannot equal 0. Now we can factor that into a plus 3, a plus 1 cannot equal 0, which means a plus 3 cannot equal 0, and a plus 1 cannot equal 0. So that implies a cannot equal negative 3, and a cannot equal negative 1. And again, that is inequality notation. For interval notation, it will be negative infinity to negative 3, union, -3, -1, union, -1 to infinity. And then part F, m minus 5 over m squared plus m minus 6. Again, we take our denominator, not equal to 0. We got quadratic inequality again, so I'm going to factor it. So that means m plus 3 and m minus 2 cannot equal 0. So that means m plus 3 cannot equal 0. And m minus 2 cannot equal 0, which means m cannot equal -3 and m cannot equal 2. And then in interval notation, that would be -infinity to -3, union -3 to 2, union 2 to infinity. Part 2, simplifying rational expressions. As with numerical fractions, a rational expression is said to be simplified or reduced if its numerator and denominator have no common factors other than plus or minus 1. To simplify a rational expression, you should factor both numerator and denominator, then cancel any common factors using the equivalent fractions property stated below. If a, b, and c are numbers where b and c are not equal to 0, then a over b is the same thing as a times c over b times c. Or similarly, a times c over b times c is the same thing as a over b. Reminder, factors are attached to each other by multiplication. Terms are attached by addition or subtraction, and cannot be canceled or reduced in a fraction. Example 3, simplify the following expressions. Well, x squared minus 2x plus 1 over x squared minus 1, factor the numerator, you get x minus 1 times x minus 1. Factor the denominator, you get x minus 1 times x plus 1. Now they have a factor of x minus 1 in common, so we would say this is equal to x minus 1 over x plus 1. When x minus 1 does not equal 0, though. Don't forget this last part. It's not something you usually include with the answer, but something you should think about when reducing. So what we started out with and what we ended with technically are not always the same. They will equal each other when x minus 1 does not equal 0. Or, in other words, when x does not equal 1. So they'll equal each other for all x values besides x equals 1. Okay. Part B, 2x squared minus 3x minus 20 over x cubed minus 2x squared. The top will factor as x minus 4 times 2x plus 5. And the bottom will factor as x squared x minus 2. Well, now there is no factors in common, so this cannot be simplified. Part C, 3xy plus y squared over 2y. You can factor a y out of the top and get 3x plus y over 2y. The y's will cancel out, and we're left with 3x plus y over 2 when y does not equal 0. Part D, 4x squared y minus y cubed over 2x squared y minus xy squared. Well, I can factor a y out of the top, and we're left with 4x squared minus y squared. Can factor an xy out of the bottom and get 2x minus y. And now the top can further be factored using difference of squares, so it becomes y times 2x minus y. 2x plus y. And then this is all over xy, 2x minus y. Well, now the y's will cancel out, and the 2x minus y's will cancel out. So this will equal 2x plus y over x when y does not equal 0 and 2x minus y does not equal 0. And that is the end of section 7.1 notes.